Welcome to Learn with Amine. In this video, we will learn about number of 1 bits. So it is a programming question frequently asked in the interviews. Basically, this problem is also called as Hamming weight. So let me explain the problem description. It says write a function that takes the binary representation of a positive integer and returns the number of set bits it has. So that means we are passing an argument which is a positive integer and it converts the number into a binary representation. Then it looks how many digits are 1. Set bits mean 1, and it counts the number of ones that binary representation has and it returns the number of ones, and that is also called as the Hamming weight. And here the input is given as 11. If you convert it into binary representation, that would be 1011, and it has 3 ones, so the output should be 3. So the intuition behind the Hamming weight function is to repeatedly check the least significant bit of the integer and shift the integer to the right until all bits have been processed. By counting how many times the least significant bit is 1, we can determine the number of 1 bits in the binary representation of the integer. So now let us jump into the problem right away. We will do it the hard way, but effective way, and then the easy way. The first thing is let us define a class solution, then define the Hamming weight as a function, and that would take the argument of the number n, which is a positive integer. Now we will be initializing a counter. Let us name it as count, and that would be 0. And this one we basically need to return this count value at the end. This will be the counter that will count the number of ones present in the binary representation of the number n. And so in order to look for the binary representation containing 1, we would have to do the right shift, and also we need to look for the least significant bit containing 1 or 0. So let us do the loop. So that would be while n is existing or it is not 0. Basically we are basically using a counter count, and we want to check for the least significant bit, that is the rightmost bit, or the bit that is ones bit, not tens, hundreds, but ones bit. It has to be 1. How do we check that? So for that we will be using the bitwise AND operation. We will be doing the bitwise AND operation between n and 1. So this will basically give us the whatever the value is present in the least significant bit, whether it is 1 or 0. If it is 1, we will be adding that 1 to the counter. Okay, and in order to, since we have already considered the least significant bit, which is the rightmost bit, now we can do the right shift. And in order to do the right shift, we will be doing the right shift by 1, but we want it to be unsigned right shift, so we will be using this particular bitwise operation. Okay, so you need to remember this. And finally, after all the bits of n has been used, this loop will end and we will be returning the count value. Now what would be the time complexity of this problem is, the time complexity would be big O of 1, because we are always processing the 32-bit integer. And again, we what will be the space complexity? The space that will be used will always be constant throughout the operation, so we can say that it is big O of 1 is the space complexity as well. Now this is the most effective solution, but if you want to remember the easy solution, let us define another function which would be named as Hamming weight 2. Again, it will be taking the argument of n. So what we told the problem description was is we want to count the number of ones in the binary representation of the number. Now to convert this number to the binary representation, we can use bin of n. So that would convert the number into the binary representation. Now we need to consider that binary representation as a string. So we will use the string of n. Now we need to return the count of ones in this string. So basically this is the count of 1 we are doing for the string n. So this gives us the count of ones in the binary representation of n. So let us use an object to access these two functions. So let me define it as a solution, and let us take an example. So the output is supposed to be 30 for this. Let us use both user defined function using my object. Okay, the Hamming weight of n, and also we can use the Hamming weight 2 function, and if we do this operation the output is 30. So this is about Hamming weight and the conversion of a number to the binary representation and then counting the number of set bits. I hope you like this video. If you like, please comment, like and subscribe. Thank you, take care, and bye bye.